Hey, welcome back to Study While You Scroll. Let's finish off this critical paths question for standard maths from the 2020 HSC. In parts 1 and 2, we use forward scanning to figure out that the length of the critical path and the activities of the critical path are shown here in parts A and B. For part C, we want to calculate the earliest start time and the float time for activities A and G. Starting off with activity A, as we can see, A is coming off the start vertex, which means that the earliest time we could start A is right away, which is 0 minutes. As for our float time, let's compare the length of A to the length of the critical path around A, as we can see in red. A has a duration of 14 minutes, and the critical path from the start to the end of A has a duration of 26 minutes. So the float time will be the difference between these two numbers. So 26 take away 14 is equal to 12, and that's why A has a float time of 12 minutes. Looking at G now, down here, the earliest start time for G is going to be how long the critical path takes to get to the start of G, which we can see from this number here is 20. So the earliest start time of G is 20. And now looking at the float time, G has a duration of 9 minutes, and the critical path around G is taking 6, 16, 24 minutes in total. So 24 minutes to get around here. G only takes 9 minutes, which means that G has 15 minutes spare, because that's the difference between 9 and 24. So that's the quickest and easiest way to find your early start times and your float times. If you need more help with your critical paths, check me out on YouTube because I've got a fair few videos that could be of use to you. Thanks for watching. See you in the next one.